Everybody, this is Mr. Beckstrom, and today I'm looking at an example from section 6B, and it says an auto transmission manufacturer receives ball bearings from two different suppliers. The ball bearings must have specified diameter of 16.3 millimeters with a tolerance of plus or minus 0.1 millimeters. Recent shipments from the two suppliers had ball bearings with the following diameters. Complete parts A through C. Now for this, I'm going to be using my TI-84 Smart View calculator, and I did supply a link to a free 90-day trial if you don't have a TI-83 or TI-84 calculator at home. So if you go to the our Moodle page here and you go under resources, if you click on this link here, if you have Windows, you click here and you can go ahead and get it here. And if you have Apple, you can click on this link right there. So make sure you download this. You get a free 90-day trial. You don't have to give them any information or any money or even your name or anything. It'll just stop after 90 days. So make sure that you do that for these problems because it's definitely needed for it. Okay, so let's kind of go back to this. So let's start off and see what they're asking. They're asking, they want to see how many of these are within 16.3 millimeters plus or minus 0.1. So that means 16.3 minus 0.1 and 16.3 plus 0.1. So if I go to my calculator here, 16.3 minus 0.1, that's 16.2, and then 16.3 plus 0.1. Looks like that goes to 16.4. So they want to see how many are between 16.2 and 16.4. That's really what they're asking here. Millimeters. All right, so they want us to first find the mean and standard deviation of each of the two data sets. Now this would be a really lengthy problem without the use of a calculator, so please don't try to find the standard deviation without using some type of either graphing or scientific calculator. Not all scientific calculators will even do this, so if you do have a calculator other than a graphing one, check Google to see if yours will even do standard deviations. A lot of them do it, but not all of them. All right. So this is what we're going to do, and I've already done some of the work beforehand to kind of save some time here. But we're going to hit stat right here, and then we're going to hit edit. And we're going to have an L1 and an L2. We should have an L1 and an L2 here. And under L1, I'm going to put all of these, and you can use the little arrow keys to move around here, and then you just enter in under L1 all of the values from supplier A, and in L2 here we're going to enter in all of the values from supplier B. Okay, so this is our lists. This is all of our lists. If you're missing a list, you can go up here. You can hit second delete, which is the little insert button there, and you can put it back in. You can hit the second 1 key, that's your L1. You see the little blue. In order to use the blue key, you have to hit the second button first. So little L1 is right above 1, the L2 is right above 2. So you can insert those back in if you need to. So for example, if I somehow lost L3, let's say that was deleted out of there and I have no L3. If I wanted to put L3 back in here, I could do second insert, and then it says what name is it, and we're going to go second 3, which is L3, and hit enter, and then it renames that to L3. So I can put those back in there like that, and I can also clear them out if I wanted to. So if I had a couple in here like 6, 3, 5, I could either delete them out manually with the delete key, or I could go right up to the top and I could hit clear, enter, and it clears the whole thing for me. All right, so once I have these in here, to find the mean and the standard deviation, the easiest way to do it is to use to go to stat. We're going to go over to calculate with the right, and then I'm going to do one variable stats. The first one I'm going to do is the L1 list, so that's for supplier A. So I had it in L2, but I'm going to change it. So I'll hit second one. That's my L1. And then I'm going to calculate it. And the mean is the X with the bar over it. So that's my mean. So my mean is, and they want us to go to, I think in this one, let me see if I still have it up here. They want to the nearest 100ths. That's 2 decimal places. So this one would be 16.35 for the mean for supplier A. And for the standard deviation, they want this SX right here. That's the sample standard deviation, and that's usually the one that they're going to ask for. If they ever ask for the population standard deviation, that's the one right underneath it, but this is less common. We only use that population standard deviation when our sample is the entire population, which is not very common in the world of statistics. All right, so this is the one that we're going to use. So our sample standard deviation, or just in this case, our standard deviation is going to be 0.08 for our supplier A. So 16.35 and 0.08. Now for the supplier B, we're going to do the same thing. We're going to hit stat, calculate one variable stats, except we're going to put in our second list there. So I'm going to hit second 2, enter, and we're going to get 16.32 for our mean, and 0.11, we round to the second decimal place here for the standard deviation, 0.11. So those are our two values for the supplier B. All right. So that's what we would put for answer A. Now the second one, it says draw a box plot for each data set and mark the tolerance on each box plot. All right. So this is going to be a little bit tricky, so you're going to need to follow with me a little bit here. I've already done this, but I want to show you how I did this. And you have to trick the calculator, because to mark the tolerance, what I did was I put in vertical lines. But since you can't really put in a vertical line since it's a function, normally, I kind of tricked it. And it's kind of a weird trick, but I'm going to show you what I did. So for the box plots, that's pretty easy. All you do is you're going to hit second y equals, that's our stat plot up here. And I'm going to go to 1 here. And so for the first one, for supplier A, I'm going to turn it on. And then I'm going to go, here's the box plot over here. It looks like this. It's this one right over here, so make sure that one's highlighted. And let's use L1. So second one. And you can make it any color you want. And then what we're going to do is, then I'm going to go to y equals, and I've already done this. So I want a vertical line at 16.2 and 16.4. So what I did was I kind of tricked it, and I put lines with a really steep slope at x minus 16.2 and x minus 16.4. You see this 9999999? What it does is it makes an extremely steep slope. It makes it like almost vertical, so it's going to make like a vertical line at our 2 tolerance levels, right? So that way it'll show me where those tolerance levels, it'll give me an idea of how many of those values are within that tolerance. So instead of just doing a vertical line at x equals 16.2 and x equals 16.4, I kind of have to trick it into making those vertical lines. So all you do is you do x minus whatever value you're trying to do the vertical line at, and you put a bunch of 9s in front like that. All right. Now, when I do zoom, and I'm going to do zoom stat, so I zoom around whatever I did in my stat plot there. So that's number 9. And it's going to look like this. So here's my stat plot. So I'm going to match it up to whatever that is in my math lab. So here's my one for the right. That's my 16.4. My 16.2, it looks like it's off to the side here. I might be able to see it if I zoom out just a little bit here. So let's zoom out. So zoom out. We're going to zoom out, and sure enough, if I zoom out a little bit, there it is too. So you can see that most of the values are within those two vertical lines there. I just have a few values that are kind of outside of it, right? And if you look up here, that makes sense, right? Because the values are 16.2 to 16.4, so they're all above 16.2, and here's 16.2, which makes sense. But we have a few that are below the 16 point, or a few that are above the 16.4. All right, now let's go ahead and do the second box plot. So I'm going to match this up with whatever we had in my MATLAB. And I'm going to go to second y equals. And the only thing I'm going to do here is go to the same one and just change that to my L2 list. My L2 list. So second L2. And go back to zoom stat. And here is this one here. And as we can see, it looks like I've got one value that's a little bit less than 16.2, right? Because it goes right here. And I might have some values that are more than 16.4 over here, but the majority of them are within the range there. That makes sense. You have one value that's just a little bit less than 16.2 and a couple that are more than 16.4, and that's what the stat plot or the box plot looks like there. All right, that's that. And then the last one is pretty easy. It just says what percentage of ball bearings from each supplier meet specification. So all we're going to do is just say it's the number that fall within this range divided by the total number. So for the first one, 5 of these fall within this range out of the 7. So I just do 5 divided by 7 and then convert that to a percentage. So just move the decimal place over twice. That would be about 71% if I round it to the nearest percent. So that would be the percent of supplier A that fall within the range, 71%. And then for supplier B, this doesn't. So it's this one, this one, this one, and this one. So 4 out of those 7 fall within range. So I just do 4 divided by 7 and move the decimal place over twice. That's about 57%. About 57%. So that would be the answer for C there for supplier B. All right, guys, I hope this helped. If you have any questions, please let me know, and I hope you have a great rest of your weekend. Thanks.